Good day, I am Stephen Gabriel Alojado, a Mechatronics Engineering graduate from Batangas State University, and today I'll be going to teach you on how we can use Festo FluidSim as our software or simulation software in creating electro pneumatic systems. So, when we say electro pneumatic system, it deals with the use of electricity with the controls of our pneumatic system. So instead of just using mechanical switches, limit switch in our pneumatic system, we now incorporate electrical wirings or electrical components with our pneumatic system. So it's for the ease of control, for better maintenance, for better presentation of our pneumatic system, especially when our devices are far. So for example, cylinders, limit switch are called field devices, so it's far away from our control board or the control panel of our pneumatic systems, especially in companies. So instead of just using basic pneumatic components or mechanical components to create pneumatic systems, we use electro pneumatics in order for us to create such system na may control tayo far away from our field devices. But nowadays, those traditional electro pneumatic system that uses EMRs or electromechanical relays and are now hindi na siya trend or parang hindi na siya lagi nakikita sa company since technology evolves, so may other means of control na, so nandiyan na si PLC. But electro pneumatics is still relevant to our knowledge as Mechatronics Engineer. Why? Because it's a strong foundation on how we can fully understand how automation works in industry, especially manufacturing industries, because you will encounter some machines that uses electro pneumatic system or pneumatic systems in short in creating their product or for example na manufacturing processes. So yun, it's important for us to have this solid foundation about electro pneumatic systems. So let's start. So first we'll be having these elements or components inside our software, inside the Festo FluidSim. So first we have to deal with supply elements. So if you have gone through the basic pneumatics subjects, so dapat alam nyo na to. So first is our compressed air. Then huwag natin kakalimutan yung air service unit. So don't forget to incorporate or make it a practice that we use an air service unit with our pneumatic diagram. Bakit? Because in real life, it represents our air compressor. So yung air compressor natin are composed of the filter, the regulator, the lubricator. So hindi naman tayo direct na kumukuha lang ng hangin. So ayun, nililinis din natin siya, nire-regulate, nilulubricate natin yung nadaanan para less yung dust na pumasok sa ating mga pneumatic components. So kahit ito simulation lang, it should be a practice for us. So yun, next would be our control valve. So for this video, example natin is 2 cylinders. I will be using 2 cylinders. So since we are dealing with electro pneumatic system, so hindi na tayo yung pneumatically operated or mechanically operated na valve. So we'll be using solenoid operated valves. So for this, we'll be having DAC. So pag DAC, double acting cylinder. So ang control nun ay obviously dapat 5 two-way valves. So let's just configure our 5-way valves. So we won't be needing an external supply of air. So yan na yan. Then if makikita nyo dito, there is a manual control with our 5-way valve. So bakit may ganun, may manual control pa rin? Dahil in real life, ang ating mga 5-way valves ay may maliit na button yan dun sa kanya, yung mga physical natin na 5-way valves, na kapag pinamas natin, it enables us to actuate the left side or the right side of the 5-way valve. So for testing purposes yan, kaya nandyan yan. So kaya ganyan yung representation dun sa template natin. And don't forget yung ating mga terminators. So just use silencer, because pag nakakita kayo ng 5-way valve physically, so makikita nyo parang gold na nakaikot nun sa buntot or sa dulo of our 5-way valve. So that's the silencer of our valves. So just connect our supply to the terminal 1, then name this solenoid. So A plus, A minus. So pwedeng mamaya na natin explain. Later na I'll explain why A plus, A minus. So next is our actuator. So since 5-way nga, we'll be using double acting cylinder, and we usually don't direct the hose from the pneumatic hose from our pneumatic valves direct to the cylinders, because we should have some control with the speed or the flow of air towards the cylinder. So we should add one-way flow control valve. So just make sure it is pointing downwards. So hindi lang siya practice with simulations. In real life then, we normally add flow control valve in our cylinders in order for us to adjust the speed or to control the speed of the extension or the retraction of our cylinder. So dito din, because if we don't use flow control valve, the extension and the retraction of the cylinder is too fast, so maybe won't be catching up dun sa sequence na ina-achieve natin. So we use this valves. So ipapantay lang natin na ganyan, then label lang tayo. So let's name it cylinder A. So after which, kapag tapos na, we'll just add another cylinder and name it cylinder B. Then ito, B plus, B minus. So I'll explain na yung sa solenoid. So A plus, A minus, it's sort of a convention or simplest representation of our control valves, because some conventions uses, for example, in our double acting cylinder, it's A 1A, then 2A. Then for our solenoid, labels are like this: 1M1, 1M2, so on and so forth. So for simplicity's sake, we use A plus, A minus. So new learners will be able to easily catch up. So it's not the convention with, or it's not the standard, but you'll be having better understanding if we represent it like this, like A plus. So A plus meaning cylinder A will extend, then A minus meaning the cylinder A will retract, same as the cylinder B. So the only thing missing here is our actuating label. So the actuating labels means our it identifies the position of the cylinder. For example, cylinder is in retract position. So for example, we name it A0. Then the position, the beginning and end position is 0, 0. So meaning when the cylinder is in the retract position, it activates A0. Ayan. And then A1 naman pag 100, 100. Same as with B. So B0, 0, 0, then B1 is 100, 100. So, yan. So, ang tawag dito is distance ruler. Distance ruler are parang guides on kung paano yung positioning of our yun nga, kung sensors man siya. Sometimes it's reed switch, sometimes it's limit switch. So, palatandaan ka lang kapag nasa gitna siya. Maybe the components used in the pneumatic diagram is reed switch. But if it's right here sa dulo, maybe mechanical limit switch. So, parang kapag nag-extend, mabubunggo ng piston yung limit switch. Kaya siya nasa dulo. Pero pag nasa gitna, since yung reed switch natin is installed at the body of the cylinder. So, maybe reed switch kapag yun yung position. So, yan. After that, we have completely created a pneumatic diagram for our that will be used later on para sa ating control. So, the control diagram will be for the next video. So, thank you for listening and watching. I hope you learned something from me, and see you on the next video. So, bye-bye.